and welcome back to Mrs. R's Science Lab, aka my house. Today we have a really fun concept for you. It's about earth science, specifically about tectonic plates and how continents move across the Earth's surface. I'm going to ask you some questions. We are going to do a little pre-quiz before I actually teach you these concepts to see how much you learn. So my first question is, what are tectonic plates? Tectonic plates are basically big slabs of rock that move on top of Earth's surface. There are two types. There's continental and there's oceanic, made of different types of material. And there are three different types of tectonic plate movement. First one is convergent. So convergent creates a convergent boundary. What do you think convergent means? So convergent means when two things converge or come together. So it's going to be when the tectonic plates come together. Next is divergent. What do you think that means? So divergent means to diverge or to move separately, apart. And the last one, this one is the trickiest one, is transform. What does a transform boundary do? A transform boundary is when two boundaries slide against each other and they break and crack and they create some crazy things. Let's go ahead and start talking about what you need for today's lab. First of all, I'm going to put on my safety goggles because if you watched my last video, I forgot them. For this demonstration, you are going to need, I have wax paper, it's easier to slide things across it. I've got a butter knife, I've got a spoon. You guys are gonna really enjoy this one because it is a food lab. You're gonna need some kind of frosting. It really doesn't matter what type of frosting. I just chose cream cheese frosting because I know I'll eat that afterwards. You will need graham crackers. So I've got two right here. Well, one graham cracker in separated in two. You will also need fruit roll-up. I got watermelon flavor or watermelon, green apple, Jolly Rancher flavored. And you will also need a cup of water. So we're going to talk about what each of those things is going to represent in our demonstration. What I think is the most fun part is the frosting. So the frosting is going to represent the top layer of our Earth that the continents and tectonic plates move across. Before I start talking about the layers of the Earth, do you know what the 4 layers of the Earth are? Think of like a pizza. The crust is on the outside. So on the Earth, the crust is on the top. It's the top layer of the Earth. So we're thinking about going into the Earth. The crust is that top layer. It's where we are right now. We're on top of the Earth's crust. Underneath the crust is going to be something called the mantle. So the mantle makes up most of the Earth's layers. It's going to be where the asthenosphere actually is. So frosting is going to represent that plastic moldable layer of the Earth that's right underneath the crust. It's part of the mantle. Underneath the mantle is going to be the Earth's outer core. The outer core is the only liquid layer of the Earth, interestingly. And then underneath the outer core is going to be the inner core. The inner core is mainly made of magnetic substances, metal, nickel, iron, things like that. And it's basically like a solid ball. So the very inside of our Earth, the inside of the Earth, the very, very core is going to be really dense. And it's basically a solid ball of rock. Outer core is going to be liquid. The mantle is going to still be hot because the inner core is where all the heat is created. And so the mantle is going to be ooey gooey towards the top, which is the asthenosphere. And then the crust is that hard rock layer that we live on top of. You will need frosting for the asthenosphere. This is what the Earth's tectonic plates slide across. You will also need graham crackers. This is going to represent our continental crust. It's going to be less dense, so density again Density is how compact molecules are in a substance. So continental crust graham crackers. And then fruit roll-ups, you're going to use this as the oceanic crust. And this is going to be really dense, so really compact, but it's going to be really thin. So fruit roll-ups, really thin. And once you have all of your items, we can get started. So let's go ahead and start with the frosting. You're going to spread this out into a small square on your wax paper. So this is the fun part. Like a lunch lady giving you your meal. What does the frosting represent again? It represents the asthenosphere. So yes, this will get messy, but that's the fun part. You spread it out so it's nice and thin, but not too thin. And it doesn't really need to be too wide either. Think of the size of the graham crackers. Those are going to go on top. I had a butter knife included in the materials in case you wanted to spread it that way, but I just used the back of my spoon. Once you have your fruit roll up, it smells so good. Brings back childhood memories. As a kid, I would always wrap these fruit roll-ups around my finger and then eat it off my finger. Like if you've ever seen the movie 13 Going on 30, she does that. And it's just so nostalgic. Fruit roll-up open. And take off that plastic backing. And you are going to actually separate this into two. If you wanted to use scissors, you could. I'm just going to be lazy and separate it with my fingers. Try not to get it to fold up on itself. You want to keep them as flat as possible. But these are going to be your oceanic plates. They're very thin, you'll notice, super thin, but they're really dense. So we're gonna pop them on the asthenosphere, just like that. And we are going to put them right up next to each other like this. Lovely. So what we have here is we have a representation of the asthenosphere with the tectonic plates, the big slabs of rock. These are oceanic plates. These are right on top of each other. I'm going to show you one of the types of plate boundaries. We'll see if you can figure out which one. Because what I'm going to do is I'm going to go ahead and separate them. And you can kind of push down while you separate them. And I want you to notice what happens to the fruit roll-ups. So what do you see here? What you'll notice is that they were separated away from each other and they're going to create almost like this canyon in the middle. This is the way that something called mid-ocean ridges are created. So if it's on dry land, it's going to cause rift valleys. It can cause canyons, but this type of boundary, do you think it's convergent, divergent, or transform? So this is a divergent boundary because it was pushed away from each other. Go ahead and take off this ooey gooey yummy looking fruit roll up with frosting. Don't eat it. We're not eating lab supplies during the lab, as tempting as it may be. I need you to go ahead and take out a graham cracker. Pop it right next to that fruit roll up like this. You need to remember that this is the continental tectonic plate. This is the oceanic tectonic plate. And we're going to put our fingers on the side of the continental plate and we are going to push it toward the oceanic plate. Oh goodness. What's happening? First of all, what you'll notice is that the fruit roll-up, aka the oceanic plate, didn't move. It's staying where it is because it's so dense. But the graham cracker, aka the continental plate, is going to go on top of the oceanic because it's less dense. So what this is called is a fancy word called subduction. Can you say subduction? Subduction, oh no, I got frosting on my lab coat. Oh wait, we can't eat the lab. Subduction This creates a crack in between the continental plate and the oceanic plate. And what can ooze out from between that? What kind of natural thing could that create? That creates a volcano! A volcano can happen with a continental and an oceanic plate, but it can also happen with two oceanic plates. The reason for that is that if they converge towards each other, so these two oceanic plates converge towards each other, they're gonna still create gaps because they're so thin and dense. Think of like underwater volcanoes. Those oceanic plates converging towards each other. Take off that lovely oceanic plate to grab both graham crackers. You are also going to grab your cup of water. Got a little chomp chomp roar. Water cup here. We are going to do something really gross. When I do this in my classroom, students are always like, can I eat this lab? Oh my goodness, this smells so good. This looks like it tastes so good. And I'm like, we cannot eat the lab. But this part is the part where they're like, maybe I don't want to eat this part of the lab. And they think that I ruin it for them. You are going to take the graham crackers and you are going to put the edges of them in water. You're going to do this for just a few seconds. Once they are watered down, you're going to take them out of the water. And those wet edges, you are going to place next to each other on top of the what? On top of the asthenosphere. And now, this type of convergent boundary is two continental plates. They are slowly moving towards each other. Do you see what's happening? Whoa. We've got two, let's say, continents, because that might be easier to think about. Two continents, which are basically two big slabs of rock. They are slowly moving towards each other. Tectonic plates move 1 to 2 inches per year. That's about how much your fingernails grow per year. So they're very slow. It's not like a continent up and decides one day, you know what, I don't like my placement here. I'm gonna go move over there. What do you think is created here? So if an oceanic and a continental converge, it creates a volcano. But if two continental, the graham cracker ones, come together, they form a mountain. So this here in the middle is going to represent our mountain. And that's because the crust, it has nowhere to go. So it's going to go towards each other and it's only going up. And take it up off the frosting. Gross, gross, gross. You have to, you can put it. Take the dry portion, so flip them around. You are going to put the dry portions next to each other. Now they are going to slide against each other. Do you remember what type of boundary that is when they slide against each other? That's a transform boundary. What is happening? It's going to go really slow, and you'll actually hear what's happening. So you hear the crumbling. So that crumbling is going to simulate earthquakes. So think of like the San Andreas Fault in California. That was created from earthquakes because when two continental plates slide against each other, they're going to create cracks in the Earth's surface and it's going to create that earthquake. Pretty crazy. I'm gonna be right back. I'm going to wash my hands real quick before we get to the quiz segment of this demonstration. So, let's see how much you learned with a quiz. There are quite a few things that I taught you in this demonstration. So I'm curious how much you actually learned. First things first, we are going to ask, what are tectonic plates? So tectonic plates are basically big slabs of rock on Earth's surface, and they move across what layer? What did the frosting represent? The asthenosphere. And there are 3 types of plate boundaries. What is a convergent plate boundary? What happens with convergent? So convergent means to come together. So they're going to converge. And that can form what kind of things? Convergent can form mountains, they can form volcanoes. What about divergent? What does that mean? So divergent means to move away from each other. They can create rift valleys, canyons, mid-ocean ridges. What is a transform boundary? Transform is when they slide against each other. And when they slide against each other, they're going to form earthquakes. Last one. What are the 4 layers of Earth? Let's start at the top. So very outside of the Earth, we're going to have kind of like a pizza, Earth's crust. Then underneath the crust, we are going to have the mantle. That's going to be the largest section of the Earth's layers. Then we're going to have the outer layer, the outer core. What's special about the outer core? So the outer core is the only liquid part of Earth. And then we're going to have the inner core. The inner core is very dense. It's basically a big solid rock made of metal inside of the Earth, and it's the very center of the Earth. Let's go over one more science concept. In science, typically before we do a demonstration or an experiment, we have to form something called a hypothesis. So a hypothesis is basically your prediction in a very specific format of what is going to happen during this experiment. I could have asked, if we were using fruit roll-ups and graham crackers and frosting, what would a convergent boundary look like? So you would say, if I was using these materials, then a convergent boundary would be, and then you make your prediction. So convergent, come together, divergent, separate, transform, slide against. It's really cool to learn about our Earth and where we live and how tectonic plates move slowly across the asthenosphere. So thank you for joining me today. I appreciate your time. I would love if you also did this demonstration at home, and if so, let me know how it goes, because not only do you get to do the demonstration and learn the concepts, you also get to eat all of this tasty food, even though you probably don't want to taste the wet graham cracker. But everything else you can eat after the lab is done. And thank you for joining in Mrs. R's Science Lab. I can't wait to hear about how things go in your science lab. Bye. Hi, another behind the scenes with Mrs. R. I wanted to show you my setup and how it looks after a messy, fun science demonstration. So fun. Now I'm gonna go eat my tasty treats.